Now let's discuss about the today's POD question. Basically, today's question is quite difficult for me, so I have left between today's POD question, but I have attempted in another DP question that is point change to. So let's see how I have solved this problem. Now let's read the problem. You are given an integer array coins representing the coins of different denominations and an integer amount representing the total amount of money. What we have to do, return the number of combinations that make up that amount. If that amount of money cannot be made by any combinations of coins, return 0. You may assume that you have an infinite number of this kind of coins. Okay. The final answer is guaranteed to fit into send 32-bit integers. Okay. Basically, we have given an array integers which is named as coin and an integer amount which represents the total amount of money, and we have to find the number of combinations and that make of that amount. It means we have to find the number of combinations of coins such that its total additions of the amount is equals to the given amount. If suppose the amount not equal to the target amount, then we have to return 0. If any combination not exists, then we have to return 0. Now let's take an example. We have given amount is 5 and coins is 1, 2, and 5. Here there are 4 ways to make up it. A single 5 is equals to amount 5, so it will come to that one. And we have used 2 plus 1. It also equals to the 5, so it is completed 1. Now again, we have 2 plus 1 plus 1 plus 1, it also equals to 5. Counted 1, that is, if we count 3. Now we have 5 times uses the 111, and it's also result to 5. That is also included in our answer. And the total way is 4. So let's see how I have solved this problem. I have got uh, prior and the recursive solution for this. I have uh, used the method of take or not take. If suppose I have take the one, then I have take again and again until it reaches to the uh, end of the array. Uh, Basically, I have when I take an point, I have do not uh, increase my index because I can take one multiple time so that it can generate an output like this. If suppose if I don't take the one, then I will proceed from index 0 to index 1 to reach the point 1. That's my simple approach. Now let's look at the code. I have declared and the size of total number of coins given. If suppose important basis amount is zero, then it will answer one because we have no coins because we have one combinations with no coins that's equals to amount zero. So I have it an amount. After that, I have declared a 2D DP matrix where it contains 10 rows and the amount plus one columns, which is filled with minus one. Now I have called the f function, which will uh, contain index as sum and n numbers of amount, given amount, points, and dp. After calling, it goes to the here and it first checks the sum of the base cases are there are three base cases here. If suppose sum equals to the amount, then it will return one. If suppose amount is greater, sum is greater than the amount, or we can say if the index is greater than the uh, and greater than equal to n, then we have to return zero. Now suppose in the DP matrix we have index and sum which is not equal to minus one. That means we have already visited it, so we can easily return the value contained in this index and sum position. After that, I have declare a t variable which contains which means I have taken the value sum plus one of IDX. I have taken the current amount, and so here you can see I have had not increase the current index because uh, we can use the current coins again and again in it equals to the amount or to is greater than the amount or it is it will be greater than equal to the after take variable I have stored non-take when I have not taken the element. I simply iterate to the next index idx plus one and sum will as it is and all the variable as it is will be passed. At the end, we have stored the result t plus take and not take in the DP matrix with the positions of IDX and sum. That's all about the problem how I solve. And let's talk about the time complexity. Basically, this function f will take total time complexity number of steps, so how many steps it will be, and the m multiply amount plus one. That numbers of the state will be created For each state, we have to iterate. So the total time complexity also with the n multiply amount you can say, and the total complexity, sorry, space complexity will be space complexity also be I think it's n multiply the term plus because we have declared the RDP matrix of size and cross amount plus one, which is total space complexity to store the all the states of the sum of amount. That's all about this problem. Thank you. Thank you for watching.